Angle between two lines. In this module, you will learn about an angle between two lines. Let us recall the equation of a line passing through a point and parallel to a given vector in vector form. Let A be a point in space with position vector A and a vector B is given. The vector equation of a line passing through A and parallel to a given vector B is given by vector R equals vector A plus lambda vector B, where vector R is the position vector of P on line L and lambda is any scalar. Here, vector B gives the direction ratios of the given line. If vector B represents A cap I plus B cap J plus C cap K, then A, B, C are the direction ratios. Let the vector equations of two lines L1 and L2 be: L1 represents vector R equals vector A1 plus lambda B1. L2 represents vector R equals vector A2 plus mu B2. The angle theta between these two lines is given by cos theta equals vector B1 dot vector B2 divided by mod of vector B1 into mod of vector B2. Theta lies between 0 and pi by 2. If L1 and L2 be two lines with direction ratios A1, B1, C1 and A2, B2, C2, let P and Q be any points on lines L1 and L2, then the position vector of P is represented by the triplet A1, B1, C1 and position vector of Q is represented by the triplet A2, B2, C2. Let theta be the angle between the two lines L1 and L2, then cos theta equals, two lines are perpendicular if theta equals 90 degrees. Two lines are perpendicular if cos theta equals 0. This implies A1, A2 plus B1, B2 plus C1, C2 equals 0. Two lines are perpendicular if A1, A2 plus B1, B2 plus C1, C2 equals 0. We now discuss the angle in terms of sin theta. We know that sin square theta equals 1 minus cos square theta. Sin theta equals square root of 1 minus cos square theta. Substituting the value of cos theta, we get, solving further, we get, two lines are parallel if theta equals 0 degree or 180 degrees. A1, B2 minus A2, B1 equals 0. This implies A1 by A2 equals B1 by B2. Similarly, B1 by B2 equals C1 by C2. And A1 by A2 equals C1 by C2. Combining all the three results, we get A1 by A2 equals B1 by B2 equals C1 by C2. If L1, M1, N1 are the direction cosines of line L1 and L2, M2, N2 are the direction cosines of line L2, then cos theta is given by mod of L1, L2 plus M1, M2 plus N1, N2. And sin theta is given by example L1 vector R equals minus 3 cap I plus 2 cap J plus 4 cap K plus lambda cap I plus 2 cap J plus 2 cap K. L2 vector R equals 2 cap I plus cap j plus cap k plus mu 3 cap I plus 2 cap j plus 6 cap k. If theta be the angles between these two lines, then it is given by cos theta equals mod of vector b1 dot vector b2 divided by mod of vector b1 into mod of vector b2. Using the above formula, we get cos theta equals cap I plus 2 cap j plus 2 cap k dot 3 cap I plus 2 cap j plus 6 cap k by mod of cap I plus 2 cap j plus 2 cap k into mod of 3 cap I plus 2 cap j plus 6 cap k. This results in cos theta equals 3 plus 4 plus 12 by square root of 1 square plus 2 square plus 2 square into square root of 3 square plus 2 square plus 6 square. Further, we get cos theta equals 19 by square root of 9 into square root of 49. This results in cos theta equals 19 by 21. This implies that theta equals cos inverse 19 by 21. In this module, we have discussed about angle between two lines. Cos theta equals mod of vector b1 dot vector b2 divided by mod of vector b1 into mod of vector b2. Two lines are perpendicular if a1 a2 plus b1 b2 plus c1 c2 equals 0. Two lines are parallel if a1 by a2 equals b1 by b2 equals c1 by c2.